Start with the new chapter, chapter 1, electric field lines. Electric field lines first introduced by Faraday. Introduced by Faraday in 1791 to 1867. For electric field lines, suppose we have a charge capital Q and electric field E, capital E, E for electric field, and distance between them is small r. For positive Q, electric field is always away from, okay. And for negative Q, electric fields towards the charge. As distance increases, field magnitude decreases. We have positive Q charge, and this charge is radially outward. As the distance increases, between these points, the magnitude always decreases. Then arrows become smaller and smaller. Understand? Length of arrow denotes the magnitude of the field. Length of arrows shows the magnitude of electric field. Here magnitude is greater, and as the distance increases, magnitude decreases. Density of lines towards positive charge more as lines are farther less. It is radially outward. And for negative charge, it is radially inward. For negative charge, here the magnitude is increases. As the distance increases, the field of the magnitude is always decreases. Towards the charge, radially inward. It is radially inward. An electric field lines is an imaginary lines or curve drawn through a region of space. Suppose we have a region and field lines in an imaginary lines. We have our imaginary line. We draw and first is point P and second is point R. These are the imaginary lines drawn through a region of space so that the tangent at any point of it is. So for P it is, for R we have tangent at any point of it is in the direction of electric field vector at that point. Understand? Is the tangent of any point. Now we have some points to remember. First, they originate from positive charge. They originate from positive charge. Suppose we have positive charge, so they are originate from it. Understand? And terminate at negative charge. Originate from negative charge and terminate from negative charge. Understand? Originate करती है positive charge से and terminate करती है negative charge से. They do not form closed loop. Do not form closed loop. Closed loop in terms of magnetic field. Next, for field lines of absolute positive charge. Field lines of an absolute positive charge. Absolute means, suppose we have positive charge, it is radially outward. We have not a fixed point, it is from infinity. Understand? It is radially outward. It is outward. Next, for an isolated negative charge, for isolated negative charge, it means from point. We have suppose negative charge come from infinity. It is radially inward. Radially inward. For two equal positive 2-point charges. For two equal positive charges. Suppose we have 2-point positive charges plus q and plus q, and we have some point between them. So is radially outward for positive charges. Then the figure become radially outward. Next, for two negative charges. We have two negative charges and point between them. Similarly, for 2 points positive charges, it is radially inward. All others are same. And for n dipole, we have two charges, positive and negative, and distance between them. For positive charges, it is radially outward, and for negative charges, it is radially inward. So the diagram between them is For radially inward for negative charges and for radially outward for positive charges. And for a large plane sheet of charge near it, lines are equal, spaced and parallel to each other. For plane sheet, equally spaced and parallel to each other. Suppose we have positive charges for sheet of paper and these are parallel to each other, equally spaced, and for negative charges these are radially outward. Comes from points infinity, equally spaced.